often when we talk about the integral is net change over time, okay? So something changed from, let's say, the velocity went from 4 to 10, okay? It changed by 6, so that's net change, all right? That's what we talk about when we talk about net change, right? So a classic example, right, is when we talk about distance traveled, right? Like we talked about a little bit in chapter 5. Okay, so one thing that I need to get straight from the beginning is you have S of t, that's position, okay? You take a derivative of that and you get V of t, and then you take another derivative and you get A of t, okay? Now, if you want to go backwards, then it's just the integral. So if you have A of t and you take an integral, then you go to V of t. And if you take an integral of V of t, then you get S of t. Okay? All right. Now, let's talk about particle motion. Okay? If the velocity is positive over a given interval, it means the particle is moving to the right. If the velocity is negative, the particle is moving to the left. Okay? So positive velocity, right, negative velocity, left. So velocity, if it has a sign, like if it's 3 meters per second, 3 means how fast it's going. The fact that it's positive means it's going to the right. Okay? Now, displacement. To find displacement, you take your velocity and you take an integral. And this, you just have to take that, you just, at face value, just memorize it, okay? So just like we have here, if you have velocity, if you take an integral, you go to this one, S of t, which is position. Displacement is how far away you are from where you started. So suppose you start here, okay? You go 5 steps forward, 2 steps back. Where are you? 3 steps forward. How many total steps did you take? 8 or 7 or 8 or whatever. But displacement is not, it doesn't count the going and coming back. It's just where you were and where you are now. So that's displacement. Now, how do you come up with final position? Okay? Suppose your initial position is at x equals 4. And you have a displacement of 3 meters. Where are you now? 7 meters, right? So your final position is the initial position plus the displacement. Now, so displacement, right? You take velocity and you integrate it. Now, total distance, remember how I said you go 5 steps forward, 3 steps back? Right, that's the total distance. 5 plus 3 is 8. The total distance, again, you take an integral of velocity, but it's got to be absolute value of velocity. Okay? And honestly, at this point, just memorize them. Okay? Just memorize the difference between this and this. All right, let's do an example. The function v is the velocity in meters per second, okay, of a particle moving along the x-axis. So it could go back and forth. Use analytic methods to do each of the following. Determine when the particle is moving to the right, to the left, and stopped. So for this, you just look at velocity, okay? So that's the sine of v of t. Where is v of t? We're given v of t here, okay? So let's just take a look at the sine of v of t. We're going to set v of t equal to 0, right? So 3t is equal to 24. T is equal to 8. So look at the domain here. The total domain goes from 0 to 10. So this starts at 0, ends at 10. That's it. Starts at 0, ends at 10. And now you have t equals 8, which is here. Okay? Now, and here we're going to do a sign chart. So below, from 0 to 8, let's say you pick 1. You plug it into V, 24 minus 3t. Do you get positive or negative? Positive, and here you get negative. So here you plug this into V. Okay? All right, so that means it's moving to the right from 0 to 8. It's moving to the left from 8 to 10. Okay, hang on. At t equals 8, how much is the velocity? 0. So it stopped at t equals 8. Okay? That's how you know. So at t equals 8, velocity is 0. It's neither moving to the left nor the right. Okay. Part B. Part B, we need to find the particle's displacement. And that's straightforward, because displacement is the integral of v of t from A to B. So that's just displacement equals the integral from 0 to 10 of 24 minus 3t dt. Okay? Okay, so here, this is going to be 24t minus 3t squared over 2. And we're going to go from 0 to 10. And we all know how to do this now. We're experts because we took a test on chapter 4 and 5 and 6, and we're experts. So you just plug them in, and we get 90 meters. So the displacement is 90 meters. Positive 90 means it's 90 meters to the right of where it started. How much it went back and forth, I have no idea. The displacement doesn't tell me that. It could have gone back and forth a million times, and then it ended up at 90 meters. All I know is it ended up at 90 meters. So that's the displacement. Now it says, if S of 0 equals 3, initial position equals 3. What is the particle's final position? Well, final position is the initial position plus the displacement. Right. Okay? You'll see it written like this a lot. Now, the initial position was at 3, plus it got displaced by 90, so now it's at 93 meters. Final position. 3 was the initial position here. Initially, it was at 3. C says, find the total distance traveled. The total distance traveled is, no, it's 0 to 10. What is total distance? Right, no, it's absolute value of v of t dt. Now, I'm going to tell you something. Plug it in your calculator. Plug it in your, don't do it now. Plug it in your calculator, integrate it. I'll do an example in a little bit. But we get 102 meters. Okay? I'm going to do another example right now. Okay?
Well, what would that look like on paper? Just out of curiosity. When you plug in BT?
Everything is in absolute value. So, you know when you do, like when you plug in the 10 minus the 0, and you do minus minus, No, it won't be minus. It'll just be like minus and the just plus minus plus.
Oh my god, yeah, that's the answer.
Yeah, look at that. Chanel says so, so we're good. Okay?
Yeah.
Fabulous. Awesome. Okay. So take a look at this. The function v of t is the velocity in meters per second of a particle moving along the x-axis. Cut and paste, same thing. Use analytic methods, blah, blah, blah. Determine when it's moving to the right, left, stopped. For this, we use v of t. So, we set this equal to 0. Okay? So now, when is sine equal to 0? When t is equal to what? 0 or pi or 2 pi, right? 0 pi or 2 pi. My domain goes from 0 to 2 pi. So here I have 0, pi, 2 pi, and this is v. Now, v was sine of t, remember? Sine of t looks like this. So in the beginning, sine of t is positive, then it's negative. So positive, then it's negative. So it stopped at t equals 0, pi, 2 pi. It's moving to the right from 0 to pi. Oops. Both open, right? Because at t equals 0, it stopped. It's moving left, pi to 2 pi.
Wait, how do you know to do brackets and parentheses?
Whenever it's part of the where it stopped, parentheses. Okay?
So one to 0 and the 2 pi being brackets too?
No, because at 0 pi, 2 pi, it stopped. So at 0 pi and 2 pi, parentheses. Okay. Displacement, yeah. Okay. Displacement.
That was on the screen, guys.
Displacement is the integral of v of t dt from a to b. All right. The integral of sine is negative cosine of t. Common mistake on the test. No, because you have bounds. Okay? So this is going to be negative cosine of 2 pi minus negative cosine of 0. All right? This is going to be minus 1 plus 1, 0 meters. The displacement is 0. Does it mean it hasn't moved? No, it just moved. It just means it moved the same distance to the right as it did to the left. Okay? Now, if S of 0 was 1, what is the final position? Final position, here's another way of writing it. Final position is the position at 2 pi. That's equal to S of 0 plus the integral from 0 to 2 pi v of t dt. Do you have to write this every time? Yeah, you do. Okay, so the final position is still where it was before. Total distance traveled, absolute value. From 0 to 2 pi of sine of t dt, put it in your calculator. 0.344.
What's right in front of the 2 pi? It says final position and it says, is that an
S of 2 pi.
Oh,
So when we do put it in the calculator, right, I'll do it one time. It's going to be math, whoops. So math, and it's the option here, 0, right? Nine. So it's f function integrate. Right? So we're going to go from 0 to, 0 to 2 pi. Okay? And then here, math, number, absolute. That's absolute value.
You can also do out row window.
You could, right. Sine of x. Is it gonna? And then dx. You have to be in radian when you're doing 0 to 2 pi. Uh-oh. We should not have gotten 4. Okay. A car moving with an initial velocity of 5 meters per hour. So the way you write that is this. Initial velocity is equal to 5. V of 0 is equal to 5. Accelerates at a rate of 2.4 t for 8 seconds.
So you need to find V.
Right, so how fast is the car going when the 8 seconds are up? So initially it was going 5 meters per hour. Now it kept going faster, faster, faster. And then after the 8 seconds, how much additional speed did it accumulate? So that's the net change, right? So what we're going to do is we have to find final velocity given that v of 0 is equal to 5 and a of t is 2.4 t. So now, the final velocity, that's v of 8, that's equal to its initial velocity plus however much velocity it gained in those 8 minutes. So this is 5, because that's what I'm given, plus 0 to 8, 2.4 t dt. So that's 5 plus 2.4 t squared over 2, 0 to 8. And that's 5 plus 1.2 times 8 squared. Altogether, 81.8 miles per hour.
What's inside the parentheses? It says it's A, like in the second line.
A of t.
Wait, so why are we finding in this case we have A,
The integral gives you how much the velocity changed, how much more velocity, the total change in velocity in the 8 seconds.
I'm saying how fast is the phone?
Right. It started at 5. It gained an an additional velocity of this much. So now, from on top of the 5, it gains a little bit more velocity, so now it's 81.8. Before, everything was in distance. Now everything is in velocity. Okay, now part B. How far did the car travel during those 8 seconds? How far did it travel? That's total distance. So that's the absolute value. Okay?
Oh, VC or?
Right. Okay, so now how do we find V of t? When you have A of t, how do you find V of t? You take an integral. So, let's see. We're going to integrate A of t dt. So this is going to be integral of 2.4 t dt. So V of t is going to be 1.2 t squared plus c. 2.4 over 2. Now, what's our initial condition here? V of 0 is equal to 5. So 5 equals 1.2 times 0 plus C. Well, 0 squared is still 0. So C is equal to 5. So V of t is 1.2 t squared plus 5. So now I have V of t, but that's not even what I want, so big deal. What I want is how far the car traveled. What I want is total distance, which is the integral of the absolute value of V of t. But now I have V of t, so I can put it into the calculator. Total distance is 0 to 8. Absolute value of V of t dt. All right, and that gives you 0.068 miles. One other thing we use integrals for is total consumption over time. So if, let's say, something is accumulating in value and so on, the integral shows you how much something changed in that time. All right? Integrals can be used to calculate growth, decay, and consumption. To find a cumulative effect of a varying rate of change, okay, just integrate. Just integrate. So look, from 1970 to 1980, the rate of potato consumption in a particular country was this many millions of bushels per year. Yes, it's measured in bushels per year. Okay, a bushel of potatoes is a sack of potatoes. So this is how it was changing right here. Since the beginning of 1970, how many bushels were consumed from the beginning of 1972 to the end of 1973? Okay, so all right, so this thing works for 1970 to 1980. So when t equals 0, the year is 1970. When t equals 10, for example, the year is 1980. Now, this is talking about, okay, the beginning of 1972, so the year is 2, to the end of 1973. How many total years is that? The beginning of 72 is 1 year. To the end of 73 is, so 2 years. So I'm sorry, so this is t equals 2, and here t equals 4. So we're going to integrate from 2 to 4 of the rate, and we don't know how to integrate that, right? Because we didn't cover it. So you're going to put it in your calculator, and you're going to get 7.066 millions of bushels. Yeah. Yeah. No. Now, here, the graph of the velocity of a particle on the x-axis is given. The particle starts at x equals 2 when t is 0. So s of 0 is equal to 2. Find where the particle is at the end of the trip. Okay? So the area underneath is the displacement. Area is displacement. So at the end of the trip, where is it? So now let's talk about what the displacement was. Okay, so we're going to find the area here. Right? What shape is that? That's a trapezoid. What's the height of the trapezoid? 2. The base 1 is 3, base 2 is 6. So that area here, we'll call that region 1. Area 1 is half times 2, 3 plus 6, and that is 9. this is area 2. That's a triangle. Is half the base, which is 4, times the height, which is 2, and that's 4. Now, yeah, I'm going to put the negative right now. So the end of the trip, the position, that's S of 10, that's equal to S of 0 plus the integral from 0 to 10 v of t dt. S of 0 is 2 plus 9 minus 4. So that's 7. Yeah. Now, the total distance traveled is 0 to 10 v of t dt in absolute value. That means it's just 9 plus 4. Okay? No negatives. 13. He's just walking. We don't care in what direction.
And no need for origin?
Yeah. Right, because it just says find the total distance traveled from 0 to 10. That's it. All right. Right, but that only counts for the displacement, not the total distance traveled. All right, I'm going to do this one, and then I'm going to let you guys go.
So are we continuing? Oh, no, we're
No, we're done.
So are we learning a new lesson?
No, we're going to do more of this stuff. I have another handout for you. Okay, email me that stuff.
Okay, I was just wondering.
There's homework tonight. No. Okay. A pump connected to a generator operates at a varying rate. Okay? How much power is being drawn from the generator to operate, depending on how much power is being drawn to operate our other machinery. So basically, the rate is varying. Now, look at units. The rate, which is gallons per minute, all right, is recorded at 10-minute intervals for 1 hour, shown in the table below. So 10-minute intervals from 0 to 60 minutes. How many gallons were pumped during that hour? So you have the rate, you want the amount. You have the rate, you need the amount. This means integrate. Now, if you're given a table, no function, can integrate. Integration, though, finds area. What other ways do we know to find area? Trapezoidal rule. Okay? So, that's going to be, and now just make sure you have minutes and you have gallons per minute. They are coherent. Each interval is 10, so the height is 10. So that means the amount, we'll call it T for trapezoidal rule, is going to be 1/2 times 10, and then it's 58 plus 2 times 65, 2 times 58, 2 times 55, 2 times 59, 2 times 60, and 163, and that's 3,575 gallons. All right, so it's being pumped at varying rates, but at the end of the day, we know how much is being pumped. This homework from the book is due tomorrow.
Wait.